Hi, Dr. Co. This is Matthew Karp, and this is part one of our two-part homework video series on the air and water closed system. And so in this video, we're going to discuss the problem that's given to us, and then what equations we're going to use to go about solving it. And then the next video will be the code that we create to actually solve the problem. So we're going to start off by drawing our system, which is just this container that's open to the atmosphere. It contains a kilogram of water. And then the initial conditions they give us are that it's at 298 Kelvin for its initial temperature, and that the initial pressure is 1 bar or 10 to the 5th pascals. So we don't know the volume of the container, and we need to find some final temperature so that the system's final pressure is equal to 2 times 10 to the 5th pascals, or 2 bar, and that the number of moles of water vapor is equal to 0.3 moles. So that gives us two statements that we can create equations from. So we're going to start with our first equation, which is going to be the pressure of our system is equal to the partial pressure of our air plus the partial pressure of our water, and that is equal to the final pressure of 2 bar, or 2 times 10 to the 5th pascals. And then our second equation is going to be for our number of moles of water vapor. So we're going to note here, like, this number of moles of water vapor is equal to, we just use our PV equals nRT, and then we're going to solve it so moles it's by itself. So that's just the pressure times the volume over RT. And then that, of course, is equal to our 0.3 moles. So let's break these equations down a little bit further so we can solve them. And so let's rewrite this one. Pressure of our system is equal to the partial pressure of air plus the partial pressure of water. Well, what's our partial pressure of air? Well, the partial pressure of our air is just equal to the number of moles of air times R times T over the volume of our vapor. And then we don't actually know how many moles of air we start out with, but we can solve for it by plugging it into this equation. So N air is equal to our initial pressure times our volume of vapor over R times our initial temperature. And to solve for this volume of vapor, we need one more small equation, which is just equal to the volume of vapor is equal to our total volume of our system, which we don't know, minus the volume of our water, which can be found by taking this 1 kilogram up here and dividing it by the density of water. And so we want to plug this back into here to get a final equation of moles of air is equal to our initial pressure times V total minus the V of water over R times our initial temperature. And then this is all equal to, this will help us find our partial pressure of air. So next we need to know our partial pressure of water, which is just derived from our Antoine equation, which we talked about in the last video, or the last homework series. And this is just going to be our saturation vapor pressure of water at the given temperature T. And then this is all equal to 2 times 10 to the 5th pascals. So right here is our first equation. This is this equation broken down. And then just to recap, this is just, all this down here is allowing us to find our total volume and then our number of moles of air for this equation. So next we need to come up with an equation for the number of moles of water vapor at the end. And we set up a similar equation to this one right here, but we just do it for the number of moles of water vapor. And so that's just going to be equal to our PV equals nRT again. So the pressure of the water times the volume of our vapor over R times T final, because we're ending with 0.3 moles. And so we don't know the volume of our vapor again, but we're going to do the same thing where we plug this in. So this is just going to be the pressure of our water times V total minus V of the water. This is all going to be over R times TF and set equal to our 0.03 moles. So that'll be all for this video. And I'll see you guys in the next one where we'll write a code to help us solve this problem.